Okay, welcome to the final part. Exact series of transformations that carries triangle ABC onto triangle A prime B prime C prime. This is tricky. Okay, so this is going to require. So if we're looking at this, we're looking at a. So what I want to do is I look at this and try and think what's going to happen. So A prime, B prime, C prime is clearly bigger. So we're going to need a dilation. But they're also not facing the same way. So we're going to need a rotation. So what we need is, so let's take C, because C's on the x-axis, so that's going to be the easiest. Okay? So C right here is 2, 0. C prime over here is negative 3, 0. So if I can rotate C over to here and then do a 1.5 dilation, because 3 divided by 2 equals 1.5, then that could do it. So what rotation takes me from xy to negative xy? And that's a 90-degree counterclockwise rotation. No, it's not. It's a 180 degree. It's negative x, negative y is what it would be. So let's see. So negative x, negative y. So 180-degree rotation followed by a dilation of 1.5. So let's see if that works for B. B, we 1, 2, down 2. So we start off at negative 2, negative 2. So 180-degree rotation is going to take me to 2, 2. And then a 1.5 dilation is going to take me to 3, 3, which is where B prime is. A prime. A is 1, 2, 3, down 1, 2, 3, 4, 5. So this is 3, negative 5. So 180-degree rotation is going to take me to 3, 5, negative 3, 5. A 1.5 dilation then, I multiply both of those by 1.5. It's going to take me to negative 4.5. 5 times 1.5 is going to be 7.5. So let's go up here and see if that works. I go 1, 2, 3, 4 and a half, up 1, 2, 3, 4, 5, 6, 7 and a half. Yay! That's it. I know that's tough, but that's how you guys got to think about it. What do I have to do? How do I spin it? How do I move it? How do I get it done? Under a dilation, triangle 0, 0, 0, 4, 6, 0 becomes triangle 0, 0, 0, 10, 15, 0. What is the scale factor for the dilation? So what we need to do is we need to divide. So we go 10 divided by 4. That's going to be 2.5. And then see if we go 15 divided by 6, which is the same thing as, if I pull a 3 out of those, I get 5 divided by 2, which is also 2.5. So the scale factor for this dilation is 2.5, or 5 over 2. Exact series of transformations. Whew. So again, we're going to need to rotate it up. That's ugly. So you'd need to rotate it up, shrink it, and then move it. This is crap. Anyway, so if we rotate it 90 degrees, okay, then, so our points A, B, C are 0, 0, 0, -6, and 4, -6. So rotation of 90 degrees gives us 0, 0, 6, 0, and 6, 4. We're then going to do a dilation of 0.5. So that stays at 0, 0. This becomes 3, 0. And this becomes 3, 2. We're then going to do a translation of xy goes to x plus 2y. So that would give us then A prime would end up at 2, 0, B prime would end up at 5, 0, and C prime would end up at 5, 2, which is where it ends up. So the answer here would be 90-degree rotation, dilation, scale factor of 1/2, and the translation of xy going to x plus 2y. And that's ugly. A rectangle QRST has a perimeter of 36 after a dilation. Rectangle Q prime R prime S prime T prime has a perimeter of 12. What was the scale factor? So we take the prime scale perimeter, divide it by the original, because it's getting smaller, right? So we need to have our scale factor be less than 1. So the scale factor then would be 1/3. If you want to leave it at 12 over 36, that's fine, but 1/3 is better. If you want to plug it into a calculator, go 0.33333. That's cool too. Okay, last row. Let's do this. Square ABCD has an area of 49 inches after a dilation is 100 inches. What scale factor is used? So we didn't do these, so we're going to skip it. If anyone's really interested, this is how it is. So the scale factor when you go perimeter is a 1-to-1 ratio. Because of area being squared, the difference is then squared. So if the relationship, if we have a square with an area of 49, that goes from 7 to 7. A square with a dilation here is going to be 10 by 10. So the relationship here is 10 to 7. That's the scale factor. So what we do is we have 100 over 49. Now, we can't reduce that, and that's not our scale factor. So what we do is we take the square root of that, and we get 10 over 7. Again, we didn't do that. I'm not expecting you to know that. Moving on. Are the following triangles similar? Oh, wait, similar? Someone say similar? Unless you're honors geometry, skip it. Are the following triangles similar? If so, what postulate supports your conclusion? So they only give us sides here, so it's got to be side, side, side. So when we set this up, what we really need to make sure is we're matching up the right ones. So this is the short side, this is the medium side, this is the long side. Short side, medium side, long side. Let's see if it works. 10 over 12 equals 15 over 18 equals 20 over 24. 10 over 12, I can pull a 2 out of each of those, and I get 5 over 6. 15 over 18, I can pull a 3 out of each of those, I get 5 over 6. 20 over 24, I can pull a 4 out of each of those, and I get 5 over 6. Are all the proportions the same? Yep. Side, side, side. Similarity. 35. Are the following triangles similar? If so, what supports your conclusion? So we have two sides and an angle in between, so we're looking at side, angle, side. So let's see if this works. 12 over 36 equals 15 over 45. I can reduce both of these. 1/3 equals 1/3. So yes. 36. I'm going to have to erase some of this. I know you guys are heartbroken about that cluster that was before. So similar again, honors only. So what we need to do first is, so we have no side lengths here. So remember, our similarity options are side, side, side similarity, side, angle, side similarity, or angle, angle similarity. That's it. So what we want to do is we want to look at this and we go, we have no sides, so that's out and that's out. So do we have angle, angle similarity? We have this 25 here and this 25 here. But then they give us the other angle. So what we have to do is we have to use our knowledge that all three of these have to add up to 180. All three of these have to add up to 180. And then we can see whether or not they match. So 100 minus 25, or 100 plus 25 is 125. 180 minus 125 is 55. Oh, there we go. Yes. Angle, angle, similarity. And that's it. So if you can do all these, you're going to kick butt on the benchmark and the final. Focus on the stuff you know how to do. Don't get caught up really on the stuff you don't know how to do. If anything doesn't make sense, which I'm sure some of this didn't, especially the higher level multiple transformations or the similarity using the distance formula, that's okay. There are a lot of questions, a lot of points on the test. Don't sit there. I think a better approach to testing is to really nail down what you have rather than sit there and try and expand what you don't know. So if you can look at it and go, hey, that makes sense, I know how to do that, awesome. If you're looking at it and you go, I have no clue what just happened there, skip it, focus on the stuff you know how to do, and really secure that knowledge. I will see all you guys tomorrow. Have a wonderful evening.